last but not least, in lesson 1, we're going to just do a little bit of arithmetic of functions. Now, adding, subtracting, multiplying, and dividing functions happens exactly as you would expect. You just add the equations together, or you multiply the equations together, or you divide. So I'm just going to run through a couple of basic examples. In the first one, I have function f and g, and we are going to write an expression for f times g, an expression for f plus g, and then we'll also evaluate f minus g of 2. So we've got a couple things to do here. So f times g of x is just going to be f of x times g of x. So that would be x plus 1 times 4x plus 3. I could definitely multiply that out, do my FOIL, and get it expanded out. But I'm going to leave it like that for now because it still has the f times the g, which is enough for what we're doing right now. F plus g of x is just going to be f of x plus g of x. And so I'm going to do x plus 1 plus 4x plus 3. And there is a little bit of combining I can do there. I can add my x's and my non-x's. And so I end up with then 5x plus 4. Now, if I'm going to do f minus g of 2, you can do it two ways. You can either do f of 2 minus g of 2, or you could write the equation for f minus g and then plug in 2. It doesn't matter. So I could do f minus g of 2. Oh, I just wrote that. I meant I could do f of 2 minus g of 2. Since I don't already have the equation, I might as well just plug it in as I go. So f of 2 would be 2 plus 1. And then g of 2 would be 8 plus 3. So I'd have 3 minus 11, which is negative 8. So pretty straightforward. Exactly what you thought they would be. Another example here, I have another f and another g. I want to find f over g of 1. Okay, so f over g of 1, I might as well do f of 1 over g of 1. So f of 1, g of 1, I'm just plugging in the 1. So I have negative 5 over negative 4 times negative 3, which would be negative 5 over positive 12. Now, when it says x values that are not in the domain, if we were to write f over g as a function, we would have x minus 6 over x minus 5 times x minus 4. Now think about domain. Domain means what you're allowed to put into a function. And in this case, because we have denominator here, we cannot put in any number that would make the denominator 0 because we know we cannot divide by 0. So I'm looking at what could I plug in that would make either one of those things 0. And it would clearly be 5 here and 4 there. So x could not be 4 or 5. These would be the numbers that are not in the domain of f over g, because if they were, we'd be dividing by 0. And that's illegal in math. Okay, we have one other way to combine functions, and that is composition of functions. And what composition of functions is, it's basically plugging one function into another. It's like nesting them inside each other. So a composition of functions f and g, we write it with this sort of open circle. So it's not the multiplication sign. It's got this sort of open circle. People often call this fog because it looks a little bit like fog. But it really means that we're going to take this g of x and plug it into the f. So f of g of x. And what that basically means in terms of a map is we're going to start, this is like our domain of g. We're going to start with this x, and it's going to be mapped by the g function to some y value. And this would be the range of g, but it's also the domain of f, because now we're going to take that same number we got out of g and we're going to apply the f function to it and get out a final value in the range of f. Okay. So it's like a two-step process. You start with a number, you plug it into the g function, whichever function is closer to the input, that's the one you start with. And then whatever you get out of that first operation, you plug that into the second function. So here's a couple of examples. Let's try. I've got a q, n, and r this time with their respective formulas. And I'm being asked to find q of r of 5. So as I said, this would mean q of r of 5. So we're going to start by taking the 5 and plugging it into the r. Okay. So I'll leave the q out here and I'm going to work on r of 5. R of 5 would be the square root of 5 plus 4, which is the square root of 9. So that would be 3. So I've started with my input value here. I put it into R and I got out 3. So now I'm going to take that number and plug it into the Q, which says square me and add 7. So 3 squared is 9, 9 plus 7 is 16. So I have one answer, not two, because the answer to a composition problem is what you get after you do both operations. You've got to plug it into the first one, then plug that back into the second one, and that's your final answer. So now we're going to do the same thing with the same two functions, but we're going to do it in reverse. So you'll notice that now the r is listed first, r of q of 5. So now you're going to start by plugging that 5 into the q. So I'll leave that r there. Q of 5 means I'm going to take 5 squared and add 7. If I square 5, I have 25. 25 plus 7 is 32. So I've done my first operation. I got 32 out. Now I need to plug that into r. And r says, take the square root of x plus 4, which is the square root of 36, which is 6. So now I've completed that composition in both directions. So number 2 is very similar. I'd like you to try that. So go ahead and pause the video and give those two compositions a try. All right, how did it go? On the first one, since the v is closer to the input value, that's where we start by plugging the -5 into the v. When we plug -5 into v, we get -2 times 25, or -50. Then we're going to take that value and plug that into the u. 2 times -50 plus 2 is -98. Then for the next one, it looks like I lost a parenthesis here. The next one, the order is switched. So we're going to start with u. We're going to plug -5 into u. That'll give us -8. Then we're going to plug -8 into v, and that'll give us -128. Last but not least, I just want to point out that you don't actually have to have an input number in order to do composition. So in both of these examples, it's just x, which means I'm going to just take the v of x equation and plug that into the u. So let's look at that. I'm going to do u of v of x, which means I'm not going to do anything to this equation for v of x. I'm just going to plug -2x plus 8 into the u function. So if I come up here to the u function, I see that my input goes here, then I'm going to add 2 to that and divide the whole thing by 3. So I'm going to take my input, which is negative 2x plus 8. I'm going to add 2 to that and divide the whole thing by 3. So all I'm doing is taking what was inside here and putting it in for the x here. I could do a little bit of cleanup there. I could at least just add the 8 and the 2 together. But other than that, there's not much more that I could do to simplify that. So my u of v of x is a new function that's still a function of x. Okay. So we're going to try it one more time in the other direction. I'm going to do v of u of x. So that means I'm going to take the entire u of x formula, which is x plus 2 over 3. And I'm going to plug that into v here. So my v function says, take my input, multiply it by negative 2, and add 8. So this is my input. I'm going to multiply it by negative 2. And then I'm going to add 8. Again, not really a whole lot you could do. I suppose we could distribute the negative 2. But we still kind of have this expression like that for what our composition would be equal to. Okay. Those can take a little practice. Sometimes it's a little hard to see and you have to work through them a little bit. So if you're struggling with that, let me know when you get to class and we'll spend some time working on it. Or shoot me a Canvas message and I'll help you out. So just a quick summary, when composing two functions, put the input value into the inside function. So whatever value you were given here, it goes into this inside function, the one listed on the right first. And evaluate that at the given x value and use the output from that operation as the input to the next function, the outside function. All right, that's it for lesson 1.